My name's Cory Minton. This is the Master of the Dark Arts session. We're going to demystify Splunk architecture. I couldn't get a fog machine. I'm super disappointed. So here's the thing. I need you all to not freak out at 2:18 p.m. What's going to happen is every one of your cell phones, probably your Apple Watches, your AirBuds, your Android, every one of these stinking devices, beautiful IoT devices, is going to go off because there's a testing of the Federal Emergency Management Association's broadcast system. What? I know it would have been more fun, but I didn't want anybody to like run over each other, like, ah! Like we don't want that, like that, because then they would think, oh well, at Cory's session, people are running out of it. We're never going to have him back here again. So I didn't want that to happen. So I'm giving you the fair warning. So that's going to happen. Don't freak out during this time, which I have absolutely no idea how long it's going to last. What I need you all to do, again, don't freak out. Let's all just hum the Jeopardy theme together, okay? And we'll see how we get through it, and then we'll take answers. So that's good. Is everybody okay with that? At 2:18, don't freak out. Your devices are going to freak out. Piece of advice, if you don't want to freak out, never look at yourself in the mirror if you're on fire, because I'm pretty sure that would freak you out really bad. Well, the only reason I know is because the people that run the conference sent it out to all the speakers that were going to be affected by it, and they're like, "Hey, buddy, you got the short straw. You're going to have an interruption." So that was the ask. So it's a test, and I don't think they send out broad alerts of tests. They just say, "It's a test," and then you freak out. Okay, but don't freak out. Remember that. Is everybody clear on this? No freaking out, man. All right, so let's go back to this. So there is a fun story. One of you will win a Google Home Mini for being here, but if you freak out and leave, you don't get to win. Okay. So my name's Cory Minton. I'm a principal systems engineer for Dell EMC. I've been at Dell EMC about 8 years. This is actually my 6th conf. It's the 5th time that I've had the pleasure of speaking to you all, and my favorite thing is there's always something new, right? Every year things change around here. There's new exciting product announcements and developments that happen in Splunk to help make it easier for you all to achieve your outcomes, right? And so we, much like Splunk, try to keep up with them as much as possible and are continuously evolving our solutions. And my job is I sit in our global technology office, which you can think of that as like an office of the CTO, where we incubate new technologies, build stuff in labs, test it, play with it, go train the teams, and then we move on to other things. Okay? I did found the Dell EMC Splunk Ninjas about 3.5 years ago now. This was basically, we responded because a lot of our customers were coming to us and saying, hey, I'm buying Splunk or I'm replatforming Splunk and I need to buy a bunch of hardware because I want to run it on premises. What do I buy? And most of our people would just look at each other and go, you said, what was it called, Splunk? So we took a bunch of people in the field and we trained them using Splunk's training methodology. So most of us carry at least a Splunk SE level 1 or SE2, which is the equivalent of an admin or and power user cert. Many of us are architect level certs, so we hopefully know as much about Splunk as you would expect us to know to be good, trusted advisors to you. I have a beautiful family of 4, and I am just insane enough to take them on travels with me all over the world when I go for work. And I do run a blog and a podcast on the side called BigDataBeard.com. That's because I'm not very creative. I have a beard and I'm into big data, and the domain was available on GoDaddy, so here we are. But the fun thing is that we get to talk. It's not an official Dell thing. It's a community-focused podcast. We get to talk with the really interesting, talented people driving technology forward around AI, machine learning, and big data. And excited to say we actually had Doug Merritt, CEO of Splunk, on with us yesterday, and that episode will publish here in the next few weeks. So if you want to check it out, it's in every app that you can find, and you can even ask your Google Home Mini to play it for when you get home. Okay. Oh, and I'm into cars. Does anybody know what that car is? Any gearheads in here? No, not a Subaru, a bigger car. But it's similar country. A Pontiac G8, made in Australia as a Holden. It's been just about converted to the race spec part, so import a lot of stuff from Australia. Massive brakes, suspension upgrades. There's no fabric left in the thing. Full roll cage. Brake vents because it's a pig when you try to slow it down going through corners, and it is real fun to put my kids in the back and go do burnouts. But there's a roll cage, so don't judge me. Okay. Hopefully we're gonna have some fun. I don't know if we will. So here's the problem. A lot of times when organizations start adopting Splunk, or they're thinking about it, or they go through this platforming thing, they start asking questions about like, what's the right way to run this? Like, how do I design the infrastructure solutions and the management orchestration tools to run Splunk exceptionally well? And what we found is that's not a widely known thing, right? A lot of people have opinions, but Splunk for a long time, for the first couple of years I was here, they didn't publish a lot of really good guidance for a while. It was like, well, you just need 12 cores and 12 gigs of RAM and 800 I/O and you're good to go. And we all knew that was not true. You needed far more than that. And there were a lot more levers to pull. And so what we seek to do is try to pull the covers back. So we want to teach you the dark arts of architecture and help you understand, like the goal being, if you are thinking about replatforming, you're deploying or you're scaling your Splunk environment, what are the things you need to think about in terms of the levers that you can pull in your configurations that have massive downstream impacts on infrastructure? Account for those, and then set some language to where you can talk with your counterparts. If you're a Splunk admin or a developer and you need to go talk to your IT operations team, like help them. We're going to give some questions to tell them what you need to tell them so that you can be successful. Is that fair? So our key takeaways, we're going to show you how our team goes through a sizing and the kind of questions we ask. We're going to understand some of the impacts that if you decide to change something in Splunk, in your indexes.conf file and other places, that it does have an impact. We're going to show you some design concepts that are quite scalable. And then we're actually going to talk to you a little bit about how we're doing it internally and some of the use cases. There was actually a talk yesterday from the Dell IT team, went into detail about it, so we're just going to gloss over it. And then I'll show you a really easy way to partner with Dell on making this super simple for you. And the other thing that's not on here is don't freak out in roughly 15 minutes. Does everybody remember why? FEMA, don't freak out. That's all you got to remember. When noise happens, don't freak out. Okay, moving on. So let's start with, I'm going to provide you a fundamental approach to sizing a Splunk deployment and give you some learned best practices. Caveat here, though, because I am 100% certain I am not the smartest guy in the room, but I'm sure many of you, even though you're really nice, sometimes you love to play stump the chump. Me being the chump, you being the stumper. Let me just say it. It's already done. You can stump me. It's obvious. But what I'm going to try to do is I'm going to tell you a lot of this that we're going to provide here is very empirical. It's based on the last 4.5 years that Dell EMC and Splunk have had an official strategic alliance relationship with Splunk. And it's also based on my team's travels around the world working with largest Splunk customers. That said, there are some experience and non-empirical things in here, so it is not 100% right every time. It's directionally accurate. Think of it as Pareto principle, right? I'm going to get you 80% of the way there, and then we'll tune from there. And that's why people have jobs. Is that fair? Okay, you're smarter than me. I'm going to assume, though, that you're at least smart enough to know a few things. So let's make a few assumptions. One, I'm going to assume that if you're here, you generally understand what Splunk is, right? Is that pretty fair? Like we've heard a lot of talks today. We saw a little bit of demos in the keynotes. We didn't really get into a lot of architecture. But what I'm also going to assume is that you generally understand that Splunk from a machine perspective is really, there's three main components. And yes, I recognize there's a handful more, but these are the main ones that we have to think about in sizing. Our forwarders are those agents, machines, or applications, calls, pieces of script, HTTP event collectors. They're the things taking data from somewhere and sending it to Splunk. And when I say sending it to Splunk, I mean sending it to the indexers. Obviously, we recognize that the stream processor now will have an impact on that, but because they didn't tell me that ahead of time, I wasn't able to get it in the slides. So just think there could be a stream processor in there somewhere else. Okay, indexers are the ones that are the most important in terms of sizing and configuration because they do the heavy lifting. If anybody's run Splunk for a while, you know indexers pretty stinking important. They handle the ingest pipeline, so the entire parsing pipeline and writing data to disk. They also are the ones responsible for handling a lot of the execution of query when you actually execute a search, okay? And then you have search heads. Search heads are where you're logging in or where you're running applications that are actually executing the reports, the queries, the dashboards that you design. So everybody got that? Everybody's cool with that? Okay. Another assumption is that you're aware that Splunk has a data tiering methodology, that the primary architecture, although we heard a different one today, we'll document it, is hot, warm, cold, and then frozen. And what this means is as data ages, it comes into the hot buckets. It's a location. Hot and warm are actually together in a thing called home path, which is they can't really be separated. They're just kind of physically together. And they're searchable. And as data ages, it goes down to warm. You can still search data in cold. We just get the option of actually taking that cold volume, all that data, and sending it to a different storage platform. We'll get into a lot of detail on that, but it gives you some options. And the idea there being that data has a decreasing value potentially as it ages, specifically in the use cases around Splunk. So they want to help you, maybe lower the cost of storing data long term, but still keep it searchable because there are many customers that still do a lot of long tail, far rearward looking searches, okay? And then if you want to keep data but you don't care about searching it because you have a compliance requirement, then there's the frozen idea. Frozen does a bunch of stripping away of indexes, writes data very efficiently down to another tier of disk, or you can just let it be deleted. Okay? Make sense there? Now, I will make an assumption. This one may not be fair, but I'm going to assume that you heard the announcement about Splunk SmartStore. Did anybody not hear it? They don't know what this is? Think of it this way, real short. It's just instead of having hot, warm, cold, frozen, you have hot, maybe a little bit of cache, then you have remote path. And today that is an S3 compatible store. So it can be AWS's S3 or it can be on-prem. You know, there's lots of storage providers that make S3 compatible storage devices. This is using S3. It's Splunk's attempt at further decoupling compute from storage effectively to help lower the TCO for many customers. Now, I do want to say this because Splunk is really excited, and rightfully so, that they've achieved this new architecture, and that's good, but I want to give you some caveats that if you don't actually go in and read the documents, which are available on Splunk's website, you may get caught up in the excitement. And the excitement is there's this announcement, which is awesome. It's a new architecture, very interesting. It does not do everything that the original architecture would do. There are certain commands in SPL that will not be supported, and there's some guidance they give you, which is if you can afford it, if you're not like freaking out under the pressure, which we're T-minus 10 minutes from freaking out, if you're not freaking out under the pressure of like the storage costs for hot, warm, cold, and frozen, like it's not crushing your existence, ending your life, you probably should stick with it. And it's going to be around for a long time. If it is crushing you, this is the thing, but you should consider this, but also understand there is a significant impact potentially. And that is if you're looking at searches, if you don't size that hot bucket correctly, you don't give it enough cache, you don't give it enough indexers, anytime you execute a search that's going back into long tail searches, or you run a lot of rare searches that are frequent rare searches, you're basically asking the Splunk cache manager to go get data from an object store. And object stores aren't designed to be high throughput, fast machines. You're asking it to send a whole bunch of data to cache and then do the queries, right? There is a better way by doing that using the traditional architecture. Understand its place in the world. I'm not saying this is wrong because guess what? I work for Dell EMC. We sell stuff to support all of it. What I'm trying to do is avoid you guys coming to me and going, I want to do this new architecture, and our team's selling you stuff, and you go, this thing sucks. I don't want that to happen. So we want to have a very candid conversation about the right place to use this, because again, it's a very neat concept. Okay, I beat that horse down. But this is good documentation. I do appreciate they published that now. Okay, so here's what happens. Splunk, and you probably all know this, the story on how you buy Splunk usually goes something like this. Somebody in your organization was having a problem. There was an outage, a breach or something. Nobody could figure out the problem. You bought Splunk. Somebody bought Splunk, or somebody downloaded the free version of Splunk. You solved the problem, and then you took it to the CTO or CIO, and you went, hey, look, I solved the problem. What is that? Oh, that's Splunk. I want to buy a lot of that. That thing looks awesome. And then all of a sudden, you're using it for everything. IoT to business applications to DevOps. You're using it everywhere, right? Well, when you start small and it's running on your laptop to running 10 terabytes a day, there's a big difference in what you need from an infrastructure to run that well. And I don't care if you run that in the cloud or you run it on premises, it's a big difference, okay? So we see scaling happen on two sort of areas. One is from a performance perspective and one is capacity perspective. If you increase your volume of ingest, you're going to need more performance, meaning like more index or horsepower. If you have crappy search performance, you fix that by adding more indexers, right? That's an easy way to solve that problem. If you add a lot of concurrent users, you will need more indexing and search head horsepower. And if you deploy any of these big premium apps like Enterprise Security, ITSI, MLTK, the VMware app, UBA, please understand that when you turn those applications on, there is a massive amount of built-in searches that get executed and run automatically. When that happens, it's like adding a boatload of users. Your indexer performance will go wah, 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 if you don't account for it, okay? Now, capacity requirements grow, and part of the reason why Splunk is decoupling compute from storage is because sometimes you don't want to have to buy compute when you're buying storage, right? That you're buying the wrong thing. So if you increase your ingest, you're probably going to need more capacity if nothing else changes, right? If you change your retention periods, that's pretty easy to figure out. We're going to go into the math in detail. If you turn on indexer clustering, that has a massive impact, right? And then, by the way, these big apps, they can also have a big impact because it depends on how aggressive you get with things like data model acceleration in the S, right? If you read the liner notes, it actually has a qualifier that says aggressive model acceleration can have up to an 8x impact on storage consumption. Like, that's great. No, it doesn't always happen that way. It's not, but understand it can, okay? So these things happen. Big apps, Retention periods, volume, really, really matter. Okay, so simple question. How many servers do I need? So if I want to deploy this on-prem or if I want to buy infrastructure as a service in the cloud, how many servers do I need to run my environment? Really simple conversation. First, understand what are the machine requirements. Sorry, there's a thing missing. I don't know why that one got out of order. So indexers. Splunk currently publishes 3 indexer categories. They have the good old-fashioned reference minimum that everybody's laughed at for 2 years. They have the mid-range. I'm not trying to be a jerk, but it's real. I mean, come on. If you're running that, it's small and it's okay. When it grows, we're going to need to get you into these mid-range or high-performance platforms, okay? Mid-range is a 24-core box minimum, 64 gigs of RAM. They publish 1,200 IOPS, but I'll argue that you should really think about it in terms of 100 IOPS per core at a bare minimum is what we've seen in our lab performance testing. High performance config is actually a 48-core box, so that's typically either a dual or 4-socket box. More RAM, and they like SSD. Massive trend in Splunk deployments today is more cores because anything in 7.0 or later got significantly better at using multi-core technology, so taking advantage of what Intel and others are doing. And they also are trending towards SSD is your friend. Right, all flash for hot and warm. Definitely all flash if you're considering the S2 or the SmartStore conversation. That's really important. Then you've got other machines. Your search heads, your heavy forwarders look basically the same, right? And then you've got these utility servers that there's really not like a hard published number. These are things like distributed management console, deployment server, cluster master, that kind of stuff. Lighter weight boxes. A couple more trends. One, up until probably a year or two ago, if I had said, and by the way, you can virtualize all of this, I would have been thrown out of the room by somebody at Splunk. I'll tell you, I have a lot of customers that are absolutely virtualizing search heads, these, and really successful virtualizing these today. And we're big fans of hyper-converged infrastructure and the virtualization there and virtual SAN technologies. We're seeing a lot of adoption of virtualization here, and I'm getting far less pushback because we've actually been able to show it's as performant. Okay, so much less concern. And I think that's true because guess what? Splunk's also looking at Dockerization, right? There's supported versions there. So it doesn't surprise me that M&O stacks like virtualization and Docker are becoming more important because guess what they did for Oracle and Microsoft and SAP 10 years ago? Okay. So from a sizing perspective, what you need to know is based on your volume of ingest, how many indexers do you need? Now, the big green bars, this is the reference, the mid-range, and the high-performance spec. This is the volume per day per indexer you should use as a maximum when considering how many indexers you need. So you can see if I have my reference indexer, they say maximum you should consider is 250 gig per day per indexer. That means if I'm doing a terabyte of ingest, I need at least 4 of those, right? If I'm not running any of these premium apps, okay? And then you can see it only goes up to about 300 for the higher performance ones. What's really important is these smaller bars, okay? Look at the difference in the amount of volume per day that this is, by the way, this was blessed by the Splunk PS team that runs Enterprise Security Services. They only want to see that reference minimum indexer handle 40 gig per day per indexer if you turn on ES. If you plan on to turn ES plus ITSI plus anything else, go ahead and drop that number in half. Right? That is a crazy small amount of like data coming in. You're going to have a massive number of servers. That's why you start to see a return on investment in some of these higher multi-core boxes, right? More core density in the server. So up in the mid-range, you can handle about 80, but even at the high end, they really only want about 100 gig per day per indexer, hitting an indexer even in that high-performance spec. So at that terabyte a day, if I'm running these, I still need 10 indexers if I'm running ES. Does that make sense? So that tells us if I have my volume per day and I know my app setup, I can back into the number of servers I need. Pretty easy, right? Not too shabby. Okay, search heads. Splunk does publish a search head table. It's available on the docs. This deck, actually, when you click on that the picture, it's actually hot linked, so it'll take you directly to the latest. But I'm generally a big fan of dedicating search heads anytime you get more than like 100 gig per day. Like it seems crazy not to have dedicated search heads. When in doubt, use a ratio of you need at least 1 search head for every 5 indexers. Sometimes that number is as low as 3, depending upon which Splunk professional services resource you talk to. Sometimes it's as high as 8, but generally 5 is generally pretty close. If you're going to be doing things like enterprise security, you want to have dedicated search heads for those. And then when in doubt, the thing that happens from a performance perspective is search performance sucks, add more indexers first instead of adding search heads. Generally speaking, they will have a bigger impact on your performance. Okay, so we had the number of indexers. Now we have a rough estimation of the number of search heads we need. So you take that sum and you use a ratio of About 3 to 1. So for every 3 of those other servers I need at least one of those other lightweight machines to act as one of these roles. And again, these are, pretty close. They'll get you close enough every time. The good thing is, and this is my argument for virtualization, if I get it mildly wrong, I just carve the VMs up differently, right? If I buy big beefy boxes that I can carve logically using VMware, how much easier does it get to deal with like asymmetrical server buying, right? Because guess what? Intel changes their chipsets, memory DIMM locations and balancing changes. There's kind of a neat argument for VMware from a scale over time. Okay? Any questions there? It's pretty easy. You now know exactly how many servers to go acquire based on volume and ingest. But what we didn't talk about was your storage. So let's talk about storage sizing fundamentals. How much do we need? Recap. For hot and warm, you have 2 options for storage. You can either use direct attached storage in the server, right? If it's a physical deployment, right? Linux, there's drives in the server. You can it's 218, y'all. Look at that. Do 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 do. This is pretty freaky. I'm not gonna lie. Oh, my watch is going off too. Wow. Well, who's this talking to him? Action is needed. Action is needed. All right, I think we're past it. Thank you all for not freaking out. That was incredible. Y'all are just great. I like y'all. Really proud. Aww. Okay, back to the really exciting storage stuff. Okay, so hot and warm, you need to have either direct attached storage in the server. And again, we like all flash, generally speaking. I think very few of you, unless you're a CFO, you're like, I want all flash. If you're a controller, you're like, do you need it? Okay, hot and warm, you can use direct attached storage in server, or you can use a SAN, okay? I'll just say this, as a company, we sell a whole bunch of SANs. I generally don't like traditional SAN technology for scale out applications like Splunk, because you run into this problem of like saturating dual controller architectures. I like scale out SAN technology for scale out applications. The way we like to think about that is software defined SAN is pretty darn interesting in the Splunk context, because it adds that additional layer of abstraction between the physical dot drives in my servers and the application that allows me to do some interesting things around, 1, performance tuning, 2, around asymmetry in terms of the server storage densities that I buy. It also allows me some additional disaster recovery options if I so choose. So again, if you have a hardware vendor who's coming in and saying, hey, I've got this dual controller SAN that you should be buying for Splunk, you probably ought to be like, really, dude? Like, this thing's scale out, bro. Like, give me some scale out tech or get out. So think about it that way. And again, we have a portfolio of stuff. I'm not saying you can't run it on SAN. We have massive customers running it on SAN technology, but if you press me and say, what's the right thing to do, that's my opinion, okay? Okay, now cold, you do have the option to run it on DAS or SAN, but you can also run it on network attached storage. So network attached storage is cool, mostly because it's cheaper than SAN or DAS typically. What's really interesting here is that you can get yourself in trouble. If you use file systems that have hard file system limits, it's a real pain in the rear for a Splunk administrator. Think about it this way. If I use a storage technology that's a NAS, and it's got a 100 terabyte file system limit, and I'm pretty sure those indexes based on 3 to 5 year retention are gonna be closer to like a petabyte, I have a management nightmare of how I'm gonna carve up file systems. So what I'm gonna end up having to do is have this scale up approach to a scale out technology. This is why we position like scale out file systems. Things like from Dell EMC, we have this Isilon thing, right? 60 petabytes in a single volume, single file system, single namespace. That stuff gets kind of interesting, okay? And then for frozen, we kind of don't care because it's dead. Why would you do that? Okay, no kidding. All kidding aside, frozen, you may need to do it because of compliance reasons, but let me just assure you, if you send data to frozen and then you have to do a massive callback of that data, it is going to suck. So if you can avoid it, if you can optimize your environment to use cold technology, like NFS, like storages like we talked about, you will save yourself a massive amount of struggle. Fair enough? Okay, so one fun myth about sizing, every one of us, Splunk people, us, like everybody, we talk about, well, I need 30 days of hot and warm. But did you know there's not a day configuration in the indexes.conf file? You actually have to figure out the math for it. But anyways, it's just kind of funny because I'm always like, 30 days of hot. Well, yeah, but we actually need to figure out the number of buckets, the size of buckets, and the max number of buckets. Anyways, boring nerd stuff. Okay, so what you do need to know from a sizing perspective, though, from a storage perspective, is not just my ingest volume, my retention. You need to understand the type of deployment you want to get. So a distributed deployment is a deployment where the data that any indexer receives is stored one time, and it's stored on that indexer. Okay? This is typically in the, like, really when you're just starting out, or if Splunk hasn't achieved the status of like being a tier 1 application where you enforce things like high availability and disaster recovery, it's not as common, right? This is, again, starter. What's more common is a clustered deployment. And again, I'm going to talk about this is in a site, so I'm not talking yet about, we'll get to multi-site in a second. Cluster deployment basically says now anytime a server gets a piece of data, I'm going to send that data to other indexers to make sure that if I fail, that data persists so that searches can persist. Make sense? So you manage a cluster deployment. Okay, again, distributed, kind of small, storage bound. So how do you figure out how much storage you need in a distributed deployment? Well, let's use a terabyte of data coming in and say that it hits an indexer. When an indexer receives data, it writes 2 sets of files. It writes the raw data as highly compressed, basically gunzip files, right? It compresses the fire out of them, writes them to disk. The other is the TSIDX, the index files, and it writes those to disk. These are the indexes are uncompressed because that's the good GUI bits that Splunk's going to go ask questions of, right? So of the data written to disk, we get about a 50% reduction in the volume of the ingest to the time it actually gets to disk. It gets about a 50% haircut, meaning a terabyte is really about 500 gig on disk. Does that make sense? So if I get a terabyte a day, I multiply it times a half, because of that 50% haircut we get from compression, and then I multiply it times my retention policy. So if my retention policy is 60 days, I need 30 terabytes of usable storage. Now keep in mind, that's the minimum. Storage practitioners should generally then add 15 to 20% for data model acceleration, free space, like scratch space, snapshots, that kind of stuff, but that's the minimum you have to have. Fair enough? Okay, so then when I get into, then if I get an indexer clustering again, this is where the forwarders are sending indexers data, and the indexers go, hey, I need to protect that. I'll keep a copy, and then I'm going to send another couple copies elsewhere. So there's 2 configurable parameters that need to be set to manage your indexer clustering. You have your replication factor and your search factor. Replication factor manages the number of raw data files, and search factor manages the number of indexes. So rep factor always has to be greater than or equal to search factor. And fun story, if you use SmartStore, they have to be the same. You can't have 3 and 2. Fair enough? Okay, so how much data do I need? So you basically figure out, okay, what is my rep factor and search factor settings? Typically, if we keep them the same, it's pretty easy math. So if I have a terabyte of data coming in, and I have rep factor and search factor set to 2, I had 500 gigs of data written to that first indexer that received the data, and then somewhere else in the indexer cluster, I spread out another 500 gigs of data. And by the way, I said it that way for a reason, because we've had, we got into some, early in our conversations with Splunk customers, they were like, oh, well, I mean, if I just use dedupe technology, then it'll get rid of those copies of data. Newsflash, it doesn't. Not very well anyway. You get like 20 to 30% reduction, not like 7 to 1 like a lot of storage vendors claimed. It's because when an index cluster gets turned on, as the data comes in, it doesn't perfectly write just one copy to a server to indexer 1 and then another perfect copy to indexer 2. It has a full copy to 1, and then it goes to all the data across the other index cluster, okay? So just be aware of that. If you hear somebody say, you're going to save 4 times, you're not. Okay. So, but by the way, it's okay. We're all here. We're trust tree. It's cool. So if you have your rep factor, search factor 2, using our math we said before, a terabyte a day, 60 days ingest, rep factor, search factor 2, you basically need, was it there? 60 terabytes, yeah. If you turn that to 3, guess what? It turns into 90 terabytes. Now we're starting to smell while rep factor and search factor kind of matter when buying storage, okay? Now, the other fun one is, I don't only need for the Splunk environment not to, fail in the site. What if I want to protect the data across sites? Where I have, a site A, site B, maybe I've got some data coming into each site and I want to protect each other. There's the concept of multi-site clustering. So you have the same option you had in indexer clustering of having a rep factor and a search factor. Now you have a replication search factor that you can set for the other side. So as data comes into site A, maybe I keep 2 copies in A, and then if I set my search factor, rep factor to 1 for site B, it'll send 1 copy to the other site. Okay, this is the preferred way to instantiate high availability and disaster recovery. Storage vendors, us included, it happens. Storage vendors and in infrastructure in general, We have a tendency of getting really excited about our replication technologies. Like we hold them up, and in many cases they are superior things that differentiate one platform from the other. Let me just tell you, from a Splunk perspective, we generally prefer this as your methodology for achieving high availability and disaster recovery, because one, it's application aware, right? So the Splunk application actually understands where those copies of data are. They're not out of band of the application. So we generally prefer this. Is that fair? If a storage vendor says, hey, replicate it, it's not that they're wrong. It's just, you might not want to do that. You're going to get less benefit to the application in doing so. Cool? Yeah.
On the previous slide, where does the 2 and the 3 multiplier come from? Is that just cushion?
Yeah, so that's rep factor and search factor. So those are configurable options. Yeah, so we just, in this one I said, let's imagine it's 2, just like this one down here, right? Imagine it's 2. And then here I just said, imagine both of them are 3. If you made 1, 2, 1, 3, here's the fun, complicated math. You then have to take the 3 and multiply, or the 2 and multiply it by 70% and the 3 by 30% and figure it out. But I'm going to show you an easier way here in a second. Hang on. Does that make sense to answer your question? There was another question back in the back. I believe that's true. Actually, I haven't looked into the covers to find out the exact answer to that question. I think it is spraying it much like it does the other rep factors. I don't think it's tied to one index. But that's a great question. You can follow up. We'll find a Splunker. Maybe a Splunker in the room knows that answer, but I think that's generally pretty accurate. I told you, 80%. I'm going to get you part of the way there. Okay. All right. Great question, though. I'm not trying to be flippant about your question. All right, so multi-site. So here's the tool that gets really interesting. So you had a question. Oh, yeah. Okay. Each site. No, we're just assuming for simplicity's sake that you have site A has some forwarders that have been, mapped to send to site A. Site B has its own forwarders, because imagine it's like a data center. We're sending stuff locally. And they're protecting it, yeah. And then what you're getting is like in 7.2, you're getting some new features where you can do like federated searches across them. You have search affinity that will happen. So there's benefits in having data on both sides. Cool? All right, so the hard part about this is then you have to figure out, not only from a capacity perspective, how much do I need in site A, I have to figure out how much is site B sending me and account for that in my storage perspective. So you got to do kind of a double math add up to get to your total storage volume. When you get into these multi-site clustering things, I'll highly advise just reach out to either your Splunk professional services resource or your pre-sales team, or you're welcome to lean on, I've got an email at the end, the Dell EMC Ninja team. We're happy to kind of walk you through some of the more complex sizing, okay? So one of the tools that is not officially supported by Splunk, even though I heard they've announced a new sizing tool, but it's not available widely yet, this is a really handy directional tool. Again, it's not perfect, it's not official, but dang, we use it a lot, and it gets pretty darn good. What it basically allows you to do is it allows you to input a lot of the things we just talked about, and then it outputs exactly what you need in terms of the indexer counts, the storage volumes, and it even, at the end of it, if you put in all those metrics, it actually even creates the indexes.conf stanzas that you can copy and paste in VI to update your conf file, which is pretty rad. So again, handy tool. I'm not recommending that it's the only thing, but it's pretty darn useful. Now, what's pretty darn useful is there's a questionnaire that we created, and I can send out a copy of it, but this is basically the questions. If you can answer these, is it 7 questions? If you can answer these 7 questions, you can run through that sizer, and you can follow the best practices we just outlined, and you could size, I'd say 95% of the environments that we've sized over the last couple of years. It's just a really simple conversation. What is it? We actually have given our field technical teams copies of this thing, and when they walk, if one of them walks into your account and you were like, hey, I want to buy some stuff from Dell, hopefully they're like, oh, I got that questionnaire, and they're going to walk you through this. They're going to take it and email it to us, and we're going to help you size it. Is that fair? Okay. So our goal, though, is I'd like to help simplify this for you so you don't have to do all of these things. So Dell EMC and Splunk came together about 3.5 years ago in a strategic alliance relationship, and the goal for us was to simplify the infrastructure acquisition and design for customers trying to deploy Splunk at scale. So what we did is we went into the labs, we looked across our giant portfolio of technology. I'm sorry they're a little dark, you can't see some of it. But we basically came out with 3 really, I shouldn't say really unique, but also really handy solutions for customers at any end of the spectrum they're at in terms of how they want to deploy Splunk. And so on the far right over here, you've got VxRack and VxRail plus Isilon. Oop, there's a build in there. I thought I killed it. So VxRail, VxRack. These are hyper-converged infrastructure solutions. VxRail being the VMware-only stack, right? It's all VMware, vSphere, vSAN, NSX. It is the simplest way to consume infrastructure for VMware. PS, Dell EMC owns VMware, so it's kind of handy. VxRack gives you the ability to do, if you want some flexibility in your, actually we'll just talk through here. If you want flexibility in terms of hypervisor, meaning I don't want to virtualize indexers, I want to virtualize everything else, and I want a little bit more feature and scalability in terms of my software-defined SAN, VxRack gets very interesting. Also, what's cool with VxRack is we can include the networking in the converged stack, so you truly have a converged solution offering for infrastructure. But if you're an organization that says, dude, I don't want to talk about VMware, I want to talk about bare metal, fastest servers on the planet, give me the best stuff in the world, guess what? Dell EMC, #1 in servers in our PowerEdge line. We have this ready bundle created that is the bare metal traditional deployment for Splunk, and we're happy to talk to you about it. So again, if you're wherever you're at in terms of your advocacy for VMware, your desire for that management and orchestration simplicity to, I just want Hall and Butt hardware, we'll meet you wherever you are, okay? One thing I will say though is Isilon is a really, really interesting technology. Basically for anybody who's doing north of about 250 gigs a day and has more than 6 months retention. Anything over 100 terabyte requirement, Isilon starts to get real interesting from a TCO perspective, like better oftentimes in most cases than cloud storage availability. Like it gets really, really interesting. Super scalable. You can put 68 petabytes in a single file system here. Very, very cool. Okay. Bucket size or volume? Total volume for cold. Yeah. Sorry, I shouldn't say cold bucket size. That's a mistype. Cold volume requirement in total. So if you need 100 terabytes for everything that's in your cold, then that's where Isilon's very good. Good catch on that. Sorry, I'll fix that. Now, if you decide, oh my gosh, I am under pressure, I cannot afford to keep doing hot, warm, cold, I love this SmartStore idea, well, guess what? We're there to meet you there too. So if you want to go bare metal, really beefy servers on, on the hot side with lots of room for cache and SSD, and you want to use an on-premises deployment of a cloud store, we have the Elastic Cloud Storage appliance. And if you're not familiar with Dell EMC's Elastic Cloud Storage, it's basically an appliance. It's a software-defined storage stack. It's basically a big PowerEdge server with our software making it an object store. By the way, that's how everybody does object. This thing's kind of cool because it geo-replicates data, so it does erasure coding over distance, so it's incredibly efficient. And we find that actually it's about 40% cheaper at scale than buying S3 straight up. Okay. Again, this is requiring you to deploy it on premises, and many organizations are like, dude, I love the concept, I just don't want to go to the cloud. Great, this is the easy button way to do it. Guess what? We were a part of the early beta testing. There's actually a document, I don't have it linked in here because it's being updated from we only found out about SmartStore 2 weeks ago, so it's being updated. But we have a deployment guide that you can actually try this for free. So there's a trial version of ECS that's run in our cloud that you can easily test this if you'd like to try it, okay? And then we actually have a deployment guide that will show you in the full version of Elastic Cloud Storage. If you want to deploy the Splunk SmartStore architecture, we actually will have your deployment guide for you. So if you want more information on that, please stop by the Dell EMC booth and we'll make sure and get that emailed over to you. Now, we've got some great customers that have done a lot of this stuff for us. So the team there's a big logistics company. We weren't told we can't talk about them exactly, but to be respectful, I mean, Doug talked about them on their earnings call last year, thanking us for getting them. Anyways, great organization, 10 plus terabytes per day, replatforming now from some traditional SAN technology, and they're acquiring this ready system for Splunk. So the virtualized SAN technology, using Isilon for cold volume archives, incredibly big cost savings from a traditional deployment. We also have a big wholesale club retailer that has all flash storage for their Splunk indexes, hot and warm, and then they actually have over a petabyte of Isilon for their cold volume archives. And they're growing pretty rapidly, but the cool part was we were able to shrink the infrastructure footprint by 30% because of the density of Isilon. Now, right around the corner is this thing called Black Friday. I know none of you would do this, but it is stunning how many of you will probably do this. Like, hopefully you're not like this young lady. She seems like a fine young lady. Hopefully you do this online in your socks, like you're hanging out. But if you go to a store, please don't be this person. But if you do sit online at your house and you go to Dell.com, what you'll find is that Dell.com and all of our Black Friday prep is actually run on Splunk. So we do all of our security and operations management of our website there. We also started using it for marketing effectiveness. So when we run, A/B testing and, various tests from a marketing perspective, all of that data is actually being monitored, managed, and reported against by Splunk. And we actually are, the field team that helps other customers go through this, we actually worked with our internal users of Splunk to go through a sizing operation like this and actually design one of our ready bundles for Splunk with them using PowerEdge servers and some of our storage. Now, I have talked a lot about running Splunk on Dell EMC and how to design a Splunk deployment well, but I will say, if you are a customer of EMC storage platforms like VNX, VMAX, Isilon, or XtremIO, like you have those platforms running in your data center, we actually have apps available in Splunk Base, as well as the tech add-ons to bring the data in, to actually monitor those solutions. Now, are they the most robust storage reporting tools on the planet? Probably not. We've spent a lot of time and energy making our own. But what they do is they get the data in for you simply, and they give you dashboards and reports very similar to what a storage administrator would care about. And it makes it very easy then to start to understand how to modify those queries for your purposes of overall infrastructure monitoring. Okay? Very simple. They're free, so you can use them, download them. There's no cost to them whatsoever. But hopefully they're helpful to you. Now, if you like any of the things that I said today and you say, well, I like it, but I want to see it, and I don't believe you can do it, well, guess what? We have customer solution centers all over the world. Specifically, our biggest ones are in Round Rock. There we have things like we've got a top 300 fastest supercomputer in the world. We've got all this stuff up and running. We can come in, demo it. If you want to see benchmarks, tests, and all that stuff, it's all there in the lab. And if you want advice and guidance on, hey, I want to run through an architecture sizing, I'd love to do it in an executive briefing at Dell, we have these solution centers to do exactly that. Okay? I'll leave you with this. We have ninjas to help you, so please understand that Dell EMC has made a massive investment in field resources who are well-trained in Splunk to help you be successful. We recognize that you have a choice in what you buy to run Splunk on, and we want to earn the right to be your provider by being hopefully the smartest and most invested in the Splunk community of any provider on the planet. And if you want to email us, splunk.ninjas@emc.com, or I'm happy to leave any of you a card up here, and I will now open it for a quick Q&A. Yeah, go ahead. Oh, thank you. You're too kind. So one quick thing I will say before we get too far into the questions, the most important question that I don't think is what you were going to ask, but it's this thing. All right, so this is like Oprah, and it's not like Oprah that you're getting one. No, it's not like that. It's under your chair. If you'll feel under your chair, one of you has one of my business cards duct taped to it. Yeah, buddy. That's my guy right there. We got a winner. All right, so sorry I couldn't go full Oprah. I had to go partial Oprah. Thank you so much for being on the show. Oh, you don't want the card? I'm kidding.